The pressurized areas are the cockpit, the avionics bay, the cabin, and the cargo compartments. An outflow valve is used to regulate the amount of air allowed to escape from the pressurized areas. Automatic control of the outflow valve is provided by two cabin pressure controllers. Each controller has an electric motor to move the outflow valve. A controller-motor combination is known as a system. Only one system will operate at any one time, with the other system acting as a backup. A third motor is installed for use in the event of both automatic systems failing and requires a manual input to open or close the outflow valve. To avoid excessive cabin differential pressure, safety valves are installed. Let us look at the operation of the outflow valve for an aircraft in cruise and what happens to cabin differential pressure, cabin altitude, and cabin vertical speed. We will start with cabin differential pressure. If the outflow valve is closed or only allowing a small amount of air to escape, then the cabin differential pressure will increase. Now let's look at what happens to cabin altitude. If the outflow valve is closed or only allowing a small amount of air to escape, then the cabin altitude will descend. We can also see what the cabin is doing by reference to vertical speed. When the outflow valve closes, the cabin altitude will decrease with the vertical speed. If the outflow valve is fully open, a lot of air is allowed to escape. The cabin pressure will decrease, and the cabin altitude will climb with the vertical speed. The crew can monitor all cabin pressure functions on the ECAM cabin pressure gauge. Let's look at the information associated with the pressurization system that is presented on the cabin pressure gauge. The pack indication is displayed green when the associated pack is on. The outflow valve position can be monitored and the system controller in use is shown. There is a single indication for the safety valves. The cabin differential pressure, or delta P, shows the difference in PSI between the cabin pressure and external pressure. This differential pressure will be at 0 on the ground and increase as the aircraft climbs. The cabin vertical speed shows the rate of change in feet per minute of cabin altitude. For passenger comfort, the pressurization system will aim to keep this rate of change as small as possible. The cabin altitude is also shown. The vent, inlet, and extract indications are associated with the avionics ventilation system and will be discussed in a separate module. On the ECAM Cruise page, there are indications of cabin differential pressure, cabin vertical speed, cabin altitude. There is also an indication of cabin vertical speed on the ECAM door page. Note that this indication is only displayed when the aircraft is airborne. On the overhead panel, there is a cabin pressure panel containing controls to operate the pressurization system. Under normal conditions, no pilot action is required on this panel during flight. The pressurization mode select switch has two settings, automatic and manual. The normal position for this switch is lights out. In this position, the pressurization system is in automatic mode. The use of manual mode and the manual vertical speed control will be discussed in the abnormal operation module. The landing elevation selector normally remains in the auto position. Landing elevation, which is required by the pressurization system, is then provided by the FMGS based upon elevation of the destination airport. If the landing elevation is not available from the FMGS, then it can be set manually using this selector. The guarded ditching switch is provided to close all valves below the waterline so that the aircraft can be sealed in the unlikely event of a ditching. When switched on, the valve forces the closure of the outflow valve, provided the mode select switch is in the auto position, the emergency ram air inlet, avionics ventilation inlet and extract valves, and the pack flow control valves. This valve is used in cold weather operations whenever the aircraft is to be de-iced. As part of your pre-flight cockpit scan, verify that the mode selector switch is in the auto position, lights out. Confirm that the landing elevation selector is set to automatic. Landing elevation is then provided by the FMGS based upon elevation of the destination airport. On the ECAM cabin pressure gauge, confirm that the landing elevation indication is auto. Once the destination airport has been entered into the FMGS, the destination landing elevation is displayed. Also confirm that the ditching switch is in the off position, lights out. We will use a cabin pressure fault where one of the two automatic systems fails. At this time, the aircraft is in cruise and all systems are functioning normally. When the ECAM system detects a failure, the appropriate caution is generated and the ECAM cabin pressure system page is automatically called. Due to the fact that this is only a crew awareness, there was no master caution. The failure message is read. In the case of a cabin pressure system 1 fault, there is no action required by the crew. System 2 is automatically activated and controls the outflow valve. After confirmation, clear cabin pressure. The status page is now displayed. There are no approach procedures to follow, and the inoperative system is Cabin Pressurization System 1. Once both pilots have reviewed the status page, clear the status page. The status page is replaced by the cruise page. We have now completed the ECAM procedure for a Cabin Pressure System 1 fault. Let's look at a second failure to illustrate the functionality of the system. We will use a dual system fault to illustrate these procedures. The aircraft is in cruise at flight level 350. The ECAM system has generated a failure message with action lines and called the ECAM cabin pressure gauge. Read the ECAM failure title, and on the ECAM cabin pressure page, observe the indications shown in amber. Read and complete the action items on the EWD, engine warning display. In this case, both automatic systems have failed. We must switch to manual mode. Notice that the Mode Select switch has an amber fault indication to help you locate it. Switch to manual mode. The indication on the switch changes to show manual in white, and a green manual message appears on the system page to indicate that the pressurization system is in manual mode. You must now control the pressurization of the aircraft by using the manual vertical speed control switch to move the outflow valve. Notice also that since you have control of the outflow valve, the landing elevation indication is no longer displayed. Let's pause the ECAM procedure and look at the use of the manual vertical speed control. The manual vertical speed switch is spring-loaded to neutral. If you hold the switch in the up position, the outflow valve slowly opens. The vertical speed will change and the cabin altitude will increase. When the manual vertical speed control is returned to the neutral position, the outflow valve will stop moving. The vertical speed will stabilize and the cabin altitude will change. Conversely, if you hold the switch down, the outflow valve will close, the vertical speed will change, and the cabin altitude will decrease. Now let's return to the ECAM procedure. Notice that the vertical speed indication is 0. This means that there is no need to adjust the outflow valve position using the manual vertical speed control. Because you have to continually use the manual vertical speed control switch, the action line is not removed. Clear cabin pressure to review status. The status page provides the pilots with information: target vertical speeds, target cabin altitudes, which depend on the flight level, and a final approach procedure to set the manual vertical speed control fully up. This ensures that the outflow valve opens completely and the aircraft depressurizes. For our example, we are at flight level 350, so the target cabin altitude is 6,500 feet. The information on the status page is very useful during descent. You will need to control the outflow valve and adjust the cabin vertical speed to achieve the target cabin altitude. After confirmation, clear status. Notice that on the cruise page, the indication of cabin vertical speed has changed to a gauge format. This, along with the cabin altitude indication, can be used to set the correct position of the outflow valve. The ECAM procedure for a cabin pressure system 1 and 2 fault is complete. We will look at some other abnormal situations of the pressurization system. The aircraft is in cruise and all systems are working normally. The caution landing elevation fault is telling you that the pressurization system has, for some reason, lost the landing elevation data normally supplied by the FMGS. Notice that the landing elevation details on the system page are blank. Read and complete the actions on the EWD. In this case, we have to set the landing field elevation manually. Select the landing elevation selector. As soon as the selector is moved from the auto position, the action line on the EWD clears and a manual message appears on the cabin pressure page. The landing elevation value will also indicate the selected value. After confirmation from the pilot flying, clear cabin pressure. Notice that there is no call of the status page because we have set the landing elevation manually and the system is operative. There is a manual landing elevation indication on the cruise page. The ECAM actions are complete. To complete this module, let's look at some other abnormal indications and what they mean. If there is an excessive positive or negative differential pressure, one of the safety valves will operate. An ECAM caution cabin pressure safety valve open is generated, and the safety valve indication on the cabin pressure page changes to amber. An ECAM caution cabin pressure outflow valve not open will be displayed if the outflow valve has not fully opened on landing. This could mean that the aircraft is still pressurized and the doors will be difficult to open. Indications on the cabin pressure page will change to amber for abnormal indications apart from the cabin altitude. If there is an excessive cabin altitude, the indication turns red and a master warning is generated.